Welcome to section 13.2. Here we're going to look at some further properties of exponential functions. And this first question on the worksheet is asking us to solve each equation using properties of exponents. Okay, so part A says 2 to the x is equal to 8. And the key to this kind of a question, as well as really all these others, is to find a common base. So notice 8 here is 2 cubed. And since I have a 2 to the x on the left, I can write this equation as 2 to the x is equal to 2 cubed. And so if those two expressions are equal, that must then mean that the exponents are equal. So in other words, x must equal 3. And that's it. All right, for B, okay, same idea. We have 4 to the x, and that's equal to 8. And again, 2 is a common base. So I'm going to write the 4 as 2 squared, and that's being raised to the x power. And then the 8 is 2 cubed. And then from our properties of exponents, it says if I have something like 2 squared and that's being raised to the x power, these exponents multiply. So that's really just 2 to the 2x is equal to 2 to the third. And then again, these exponents must then be the same because the base of the two expressions are equal. So I have 2x is equal to 3. So x then must be 3 over 2, or 1.5. Okay. How about C? 8 to the n is equal to 4. Well, much like what we saw with B, there's a common base of 2, so I'm going to write the 8 as 2 cubed, and that's raised to the n. 4 is 2 squared, so then I have 2 to the 3n is 2 squared. Then I can go ahead and equate the exponents because the bases are the same, and so here n would be 2 thirds. Okay, great. D, I have 25 to the y equals 1 over 125. Okay, so for something like that, 5 would be a common base because 25 is 5 squared. That's being raised to the y power. And then 125 is 5 cubed, but notice it's 1 over 125. So I can write that as 5 to the negative third power, because remember a negative exponent here is telling me to take a reciprocal. Okay, so now I have 5 to the 2y is 5 to the negative third. And so equating exponents now gives me 2y is negative 3. And so then we get that y is minus 3 over 2. All right. For E, 1/2 to the x plus 5, and that's equal to 32. And we see that 2 is a common base because 32 is 2 to the 5th power. And now here I also have this reciprocal thing going on. It's 1/2. So what I can do there is I can say this is 2 to the, not x plus 5, but negative x plus 5. Because that negative would say take the reciprocal of 2 to give you the 1/2, and then you have that exponent of x plus 5 there. All right, great. So now I'll go ahead and distribute this negative to the x into the 5 up there in the exponent. And I can also equate exponents because I have a common base. So I really have minus x minus 5, and that's got to equal 5. So now adding 5 to both sides would give me that negative x is equal to 10. So then it looks like x would have to be minus 10. All right. For F, 1/9 to the m minus 2, and excuse me there, I forgot the right-hand side. That's 1 over 81. Okay. Well, 81 is 9 squared, and so we could use a common base there of 9. And then much like what we just saw in E, since I have a 1/9, I'm going to say this is 9 to the minus the quantity m minus 2. And then 1 over 81 would be 9 to the minus second power. All right, and now common base, so I can equate the exponents, and I'll also distribute this negative, just like we did in the previous problem. So we got minus m plus 2 has got to equal then negative 2. So now subtract 2 from both sides, and you'll get minus m is minus 4, and then we get that m is 4. Okay. For g, 5 to the x plus 1 is equal to 125 to the x minus 3. Well, like we saw in D there, right? 125 is 5 cubes, so I can use a common base of 5. So I already have the base 5 on the left, so now I'm going to write this as 5 cubed to the x minus 3. All right, so now on the right-hand side, the 3 and this entire quantity x minus 3 will multiply, okay, because these exponents, just like we saw here in part B, these exponents multiply, but this 3 here is really going to distribute there, okay? So that's going to give us 5 to the x plus 1 is equal to 5 to the 3x, and then that would be at minus 9. And now I have a common base, so I can go ahead and equate exponents. And here, if I subtract x from both sides, I'll get a 2x. Adding the 9 over, I'll get a 10. And the 10 divided by 2 will give me an x equals 5. So there's the solution there for g. And then lastly, h, 3 to the t plus 4 is equal to 9 to the t minus 5. Well, since 9 is 3 squared, we can use 3 as our common base. So I have 3 to the t plus 4. That's going to equal 3 squared to the t minus 5. And now, just like in part G, this exponent of 2 will multiply this exponent of t minus 5, but again, that 2 is going to multiply this entire expression, so it actually distributes. So we'll get 3 to the t plus 4 is equal to 3 to the 2t minus 10, and now we can equate exponents. We have t plus 4 is equal to 2t minus 10, and so then subtracting t from both sides will give me just a t on the right. Adding 10 to both sides would give me a 14 on the left. So it looks like t would have to equal 14. And that will do it. All right, thanks.